We're going to be looking at cosine law, at how to develop it and how to use it to solve for sides and angles. Previously we've looked at, we call it SOHCAHTOA, using primary trig ratios, sine, cosine, and tangent to solve for sides and angles in right angle triangles. And then more recently we've looked at sine law, how to use sine law to solve for sides and angles in triangles that don't have a right angle. And we saw that sine law worked in any triangle where we had three pieces of information as long as two of those pieces were an opposite pair of an angle and the opposite side length. Today we're going to be looking at cosine law, how to develop the cosine law first of all, and we're going to start with that first. We're going to begin that doing the same thing that we did when we developed the sine law, which is to add a height or an altitude to this triangle that doesn't have a right angle in it, but we want it to have a right angle in it, so we're going to add a height, and we're going to call that h. And then, because this is the cosine law, we're going to say, well, if that's true, then what does cosine of b equal? And of course, cosine, you know, as a primary trig ratio, cosine equals adjacent over hypotenuse. The adjacent side of, in this right angle triangle, the adjacent side of angle B is this side right here. Now, it's tempting to say that that's A, but that's not true. A goes all the way from B to C, but we only want from there to there. That means that we have to break this side up into two pieces. And I'm going to do that by saying, well, this little section over here from where the altitude hits to where C is, I'm going to call that X. And if the whole thing is A, then that means this section must be A minus X. Right? So that means cos B must be the adjacent side, which is A minus X, and it must be over the hypotenuse, which in this triangle is C. We're also over here going to say, well, what does cos of angle C equal? And, well, it equals the adjacent side, which is X, over the hypotenuse, which is B. We're going to leave that there for now, and we're going to look at our two right angle triangles and say, well, right angle triangles, you can always do Pythagorean theorem on them. So we're going to set up this guy and say, well, this side squared plus this side squared equals the hypotenuse squared, just like in any right angle triangle. And so we're going to set that up and say this side is A minus X, and we're going to say that's squared, plus the second side, H squared, equals the hypotenuse side, C squared. And I'm just going to expand and simplify that, right? We're just going to FOIL that, and that, of course, is a squared minus 2ax plus x squared plus the h squared equals c squared. In this other smaller right angle triangle here, I'm going to know that x squared plus h squared, right, is an easy one. X squared plus h squared equals the hypotenuse squared, which in this one is b squared. Now, so I have four relationships, I guess. A cos relationship over here, a cos ratio over here. I have this relationship and this relationship. And if I look at these two, they both have a couple things. I guess they both have an x squared. They also both have an h squared. And since h squared is the same thing for both of them, I'm going to actually rearrange both of them to become h squared equals, right? So that means I'm going to have my c squared. I'm going to subtract a squared from both sides. I'm going to add 2ax to both sides and subtract x squared from that side. And on this one, h squared, of course, is just b squared minus x squared. And since I have h squared equals over here and h squared equals over there, I'm going to sub one into the other, sub them into each other, or set them equal to each other. And I get c squared minus a squared plus 2ax minus x squared equals b squared minus x squared. And I happen to kind of know where this is going, so I'm going to say that I want all of this to be on one side of the equation, and I want it to equal c squared. So what do I have over here? B squared minus x squared, and I have to add a squared to both sides, subtract 2ax from both sides, and I need to add x squared to both sides. If I look at this, I have a minus x squared and a plus x squared. Those two things, when I add plus and minus x squared, they disappear. My x squareds disappear. And so I'm going to rewrite this. And again, because I know where this is going, I'm going to actually switch the order of a squared and b squared, right? But b squared plus a squared is the same as a squared plus b squared minus 2ax. And I'm doing pretty well here. I've got this thing written together in terms of c and a and b, but I have this x, and it's going to be pretty rare that I know what x equals in this triangle. So I'm actually going to take this relationship, this cosine ratio that we developed at the very beginning, and say, well, if cos of c equals x over b, I can multiply both sides by b and get that x equals b times cos c. And I'm going to actually sub that in for x here. So it equals x here, so subbing in for x, I get that c squared equals a squared plus b squared minus 2a, and I have times b times cos c in for x. And this right here is our cosine law. Now, cosine law can be used in a lot of different places. It's used when you know three sides of a triangle. So if I knew C, A, and B, then I could solve for this angle C. Also, if I knew two sides and the angle in between the two, and so we call that a contained angle, then I could solve for the third side. So it's useful in the couple places where sine law isn't useful. So this uses C, A, and B, and like if I repeated this whole process and kind of added a height somewhere over here, I would probably get some kind of relationship that said a squared equals b squared plus c squared minus 2bc cos a. And if I were to add a height somewhere along these lines, same deal, and work through this whole process again, I might see that, or I know I would see that b squared equals a squared plus c squared minus 2ac cos of angle b. So there are different versions of the cosine law, but they all have that the square of one side equals the squares of the other two sides added together, minus 2 times the other two side lengths times the cosine of the angle across from the side that you are finding. Right? So this will work in all cases where you have a triangle, a non-right triangle, where you know the three sides, or you know two sides and the contained angle between them.